Welcome back to lecture. In this lesson, I would like to talk about estimating in a number sense. So what are educated guesses and estimations? We frequently have to do that in math, and we don't have a calculator ready. We don't, and we don't really need the precision of an exact answer. We just kind of want to know about about what the range of values would be, or just some idea. So educated guesses and estimations. Guessing does not mean just throwing out a random answer and hoping you are correct. Instead, we use the information we know to be true and some reasoning ability, and to determine a close answer. That's what we're looking for. So it's often the case that we can figure out some likely wrong answers even when we have no idea how to find the right answer. We can eliminate these things. When we narrow down, and that one would be the case if I have a multiple choice and I'm going through and I'm saying, okay, this isn't possible. This is way too big. This one is way too small. This one is about what we're looking for. When we narrow our options in this way, we give ourselves a better chance of guessing correctly when we finally do guess. Okay, it may be a guess, but it's a reasonable guess, I would say. In order to narrow our options effectively, though, we actually have to have studied this in advance. This is not something that you just know how to do. So here's the techniques. Estimation. Does the problem contain the word approximately or something similar? That we just kind of want to recognize when do we need to just estimate. So approximately, estimate, something similar to that. Are the numerical answer choices decently far apart? Is there like, 10,000, 50.005, those type of things, and we can kind of get a feeling of all we want to know is just how, something that's close. Is there a diagram? Can we draw one that would allow you to estimate? If we're reading a graph or something, we can look at maybe the scales and just kind of work between the scales. Can you assess things in terms of more than half versus less than half? More than half, less than half, approximately half. This often works well on probability, sets, rates, work, fraction, percent. Can you assess things in terms of positive versus negative, or greater than 1 versus less than 1? That often works well with number theory. So here again, we've got working with multiple choice. Are the answers generally small, easy numbers? Try them in the problem. Start with B or D after every choice. If that choice is wrong, to try to determine whether you need a larger or smaller number. If I have some formula or something, I can kind of put those in there to get a good idea. For example, let's say that we try B first. It's wrong. And we can also tell that we need a larger number. A is smaller, so cross off A as well. If everything's kind of increasing, the larger the sizes, the answer should be larger. So we tried D, it's wrong too, but we can tell that we need a smaller number. Therefore, the answer is C. So we're kind of looking for the range of things that's in there. You can never tell where you need a smaller or larger number, then you never need to try more than a couple of choices in order to get the answer. Are there variable expressions in the answers? Try picking your own easy numbers to find an answer that works. Even if you find that 2 answers works, happens sometimes, at least you've narrowed it down to 2. So when are you going to make educated guesses? The SAT, ACT, the GRE, the GMAT, the bar exam, a lot of other standardized tests will ask you to make educated guess to determine an answer. Here's something that that we'll look at, an isotherm. Isotherm, let me move me down here just a second so we can see the results here. An isotherm is a curve on a map that connects the location where the temperature is the same. Isotherms, isobars, pressure the same, iso meaning the same. So there's many times you'll kind of look at this thing. So use the map below to estimate the temperature of each city. So we would go here and we would look for, here's Las Vegas, Nevada, that's L, that would be like here, And Phoenix, Arizona is P right here. Here's a 40 degrees, here's a 50 degrees. So all along this line is 40. Go right here, let's say something that goes straight across. About halfway would be 45, so I would say that's about 48 degrees. Okay, and it's just an estimation. You may say 47, 49 maybe, but I'm just saying that's a close value anywhere in there. Okay. So the Las Vegas was directly on the line. That's 40 degrees. Phoenix was in between. I'd say that's the 48. Dallas, here's between 20 and 30. About halfway, right? Halfway between the 20. Here's the 30 on this isotherm. So about halfway, I'd call it 25. Let's look at Springfield, Illinois. Here's 0 and here's 10. If I did a halfway kind of perpendicular through here, I would say that would be about half. That's another half. So let's call that about 7.5. 7.5 degrees, 8 degrees, anywhere in that range. Atlanta, Georgia. So here we're looking at quite a bit distance. So this really flares out. Halfway between here and here, I would call maybe a 35. And then that looks to be a half again, 32.5 or 33. Miami, Florida. Miami is just above, and as we're increasing, I'm assuming this is increasing a little bit. Since we really have no good gauge here, maybe call this 51, 52 degrees. We know it's a little above 50. Okay. And then New York, New York. There's that one. That's the end. We're right above or right below there, and that's going down in -10. So let's call that maybe, if that was -5, maybe -1.5. So minus 1.5 there in New York City today. Okay, so that's isotherm estimation. I hope you enjoyed the lesson material. We will see you next time. Have a good day.